Hey guys, I have your notes here for section 5, 1, day 2. And also with me, I have my page of tables because we'll make several substitutions from this page today. So I'm going to run through 3 examples with you to try to get you, just to give you some new ideas on how to get through maybe some harder proofs that you'll encounter today. So here's what we're going to do. We're going to start with the more complicated side first, just like we did yesterday. We could try turning everything into sines and cosines like we did yesterday. We're going to be finding a common denominator several times today, like we did yesterday. The problems just get a little harder. So let's check out number 1. We're going to start with the left side. Now, if you want to, you can change this to 1 over sine over here on the right, or you can just leave it. Since this is a proof, you have to show every single step. So since you have to basically rewrite the entire equation every single time you do something to it, I think I'm going to keep this as cosecant because it's less writing than 1 over sine. All right, so this problem contains 2 fractions, and it's trying to get me to add those fractions together. So in order to do that, I need a common denominator. My denominator on the fraction on the right is simply a one-term trig expression. It's just sine of theta. My denominator in my fraction on the left is a binomial. It has 2 terms. So in my common denominator, I need one of each. I need this monomial times this binomial. So this fraction on the left needs a sign out here beside it. So I'm going to come out here, I'm going to multiply this by sine of theta over sine of theta. Let me go ahead and do that, and I'll write what I get. So sine times sine, I get sine squared on top over, and then I've got that, which I just put there, times what was originally there. There you go. So the fraction on the left, I now have the original denominator and that one as well. So that's what my common denominator is going to look like. The fraction on the right, this one, I need this whole quantity in this denominator. So, well, what the heck? There we go. I'm going to multiply the top by 1 plus cosine over, I'm going to multiply the bottom by 1 plus cosine. Now, here's the thing. I am going to multiply this cosine times each of these terms on the top. So on the top of this fraction, I get cosine times 1 plus cosine times cosine. Now, on the bottom, I have the one that was originally there and the one that I put on as well. Equals cosecant theta. Okay, it's a lot of writing, I know, but it has to be done. So, suggestion. Suggestion. Always multiply out your numerators. Here's what I mean by that. I multiplied sine times sine, and I wrote sine squared. I multiplied cosine into this binomial. I distributed cosine into this, and I got this. Always multiply out your numerators. Don't multiply out your denominators unless you have a really good reason. Do not multiply your denominators unless you have a really good reason. In fact, write that over here. Do not multiply out my denominator unless I have a really good reason. And I hope when we get a little bit farther in this problem, you'll see why I said that. All right, so now what? We got a common denominator. So I still have this fraction, but now they have common denominators, okay? Since they have a common denominator, let's join our fractions together by combining what we can on top, leave the bottom the way it is. Now, who sees what we can do in that fraction? Careful. I've got a sign in my classroom on the front of my podium. When you cancel illegally, every time you cancel illegally, a kitten dies. So every time someone sees like this and says, oh, I'm going to cancel out these X's, you just killed a kitten. Every time you cancel illegally, you kill a kitten. So be careful. There's a lot of kitten killing that could be going on right now. No, you may not cancel this sign with this sign, or one of these with this one. Why? Because these are connected with addition. You can't cancel this cosine with this cosine. Why? Because these are connected with addition. So, you have to be able to do something. And here's a hint. Ready? Here's a hint. I'm going to highlight it. This is what I want you to see. I've got a sine squared plus a cosine squared. That's a thing. What is sine squared plus cosine squared? It's just 1. So these two blue pieces come out and we sub in a 1 in their place. 1 plus cosine theta over we're almost there. Can this cosine cancel with this cosine? Absolutely not, because this is connected with addition. However, can this whole term right here, sorry, no, that's not a term. Can this whole quantity cancel with this whole quantity? Well, how is this quantity connected to this quantity? It's connected with multiplication. That's legal. When two things are connected with multiplication, you can cancel. But if there's addition, keeping them connected, then you can't. So I can cancel this whole quantity with this whole quantity. That's totally legal. And after I do that, I'm left with 1 over sine on the left. And to save myself an extra step of writing, why don't I go ahead and change this one now? And now they'll match and I'll be finished. Finished. We just prove that this is a true identity. It's true for all values of theta. Next one. This one's the more complicated side. Let's start over here. And unfortunately, you can't get a common denominator by adding something on. You have to multiply it. So unfortunately, we're going to have to use one of these quantities and one of these quantities in our common denominator. Ugh. So this one over here, I need to multiply by 1 minus sine theta. 1 minus sine theta. Here's what I get. I need to multiply the second one by 1 plus sine theta. 1 plus sine theta over 1 plus sine theta. Here's what I get. Okay, got a common denominator. Remember how I said, go ahead and multiply out your numerators. Well, there wasn't much to multiply. I multiplied them by 1, by whatever. Don't multiply out your denominator unless you have a really good reason to do so. So here I go. Since I have a common denominator, let's combine my fractions. So collect like terms, I get 2. 2 over All right, this is a really good place to be. I said don't multiply out your denominator unless you have a really good reason. So often you're going to get stuck. You're going to get stuck and you're going to think, I don't know what else to do. How on earth am I going to make this look like this? Okay, why don't you change this one up just a little bit? Why don't you see what you can turn this one into and see if that helps? I could call this one 2 over, let's see, a replacement for secant squared is 1 over cosine squared. So cosine squared x. Now, check this out. Still there. Still there, and then I have 1 over cosine squared x, so I just put 2 over cosine squared x. How on earth do you think you can turn all of this into one of these? How can that become cosine squared? Well, if you FOIL this out, see how they're exactly the same, but one's a minus and one's a plus? If you FOIL this out, your outer and your inner terms are going to cancel. And here's what I'm left with. First, 1 times 1. Outer, positive sine theta. Inner, negative sine theta. Gone. Last, a negative times a positive. Sine times sine. Oh, sorry, it's a theta. I got so excited I wrote the wrong thing. Oh, why do I have x's and thetas? That's just silly. That is so silly. So silly. Okay, now we're pretty much finished. What is 1 minus sine squared? That's a thing. That's on your paper. Look it up. 1 minus sine squared. Make that substitution. So I'm going to turn this into cosine squared. Right side, Stays the same. Finished. We proved that that was an identity. All right, last one. Let's get a common denominator. Don't multiply out the denominators unless you have to. Over here, I need this binomial. All right, you're not going to like this, but multiply out your numerators. I need you to FOIL these two. Binomial, I need you to FOIL them. Ready? First, outer, inner, last. Combine your fractions together. So I've got cosine squared plus 1 plus, I've got 2 sines, so I'm going to do that. Sine squared all over, holy moly. You should see it. I think you should see it. You know what that makes. Sub it in. So the blues made a 1. There was a 1 already there. I'm going to go ahead and write 2 plus 2 sine x all over we're close. Don't multiply out your denominators. We're close. Ready? The reason I don't want you multiplying out your denominators is because I'm hoping something will cancel. I'm hoping you can cross one of these out with something on the top. Now, you all know over here, you can just kind of tell by using your imagination or whatever. This is going to be 2 over cosine, right? Because secant is 1 over cosine. So this is 2 over cosine. Which one of these quantities do you think ought to cancel? This one ought to cancel. So look up at the top. What's keeping you from canceling this quantity with the one on top? The one on the top has a 2 in both terms. Pull it out. Pull the 2 out. Here's what you get. Pull a 2 out of this, you get a 1. Pull a 2 out of this, you get a sine x. Ha, now we're gone to something. Now we're on to something. The whole entire quantity can cancel. How do I know? This quantity is attached to the 2 with multiplication. This quantity is attached to cosine with multiplication. They may cancel. So on the left, I have 2 on top and a cosine on the bottom. And to save a step, I'm going to go ahead and change this to 2 over cosine. Yay! We just did another proof together.